Chapter 12 is all about the character functions in SAS. For some of the programs to run properly, I first need to run the create datasets code that goes with it. So when you're looking at the code I have here in my video, you may see a chunk from the create datasets file right above the program that we see inside the chapter. I won't have time to demonstrate every single program from the chapter, but I will talk through the functions. In program 12.1, the function of interest here is the length n function, and it returns the length of a character value. For the data set that we're looking at, this learn.sales data set, there is a name variable, and it actually includes first and last name. And these in the data lines are of varying length. And what we're achieving with this piece of code is a subset that contains only the names that are greater than 12 in length. Let's run this and take a look. And we see only Glenda Johnson. Hers was the only name that was long enough to meet that requirement. In program 12.2, the functions we're looking at are for dealing with upper versus lowercase values. Sometimes names are not given or supplied to us in a standard way. We notice that in this learn.mix data set, Thomas's last name is not capitalized. We have two different functions that deal with case. Uppercase will change every character to uppercase, whereas propcase will change just the first letter of each word and make it uppercase, and the remaining will be lowercase. Notice we have both situations. In name 1, we have the uppercase results, and in name 2, we have the prop case results. In program 12.3, the compress BL function, or comp BL, removes extra blanks. And here we're seeing it in combination with prop case. We also have upcase because we're dealing with addresses. We want to get rid of any excess spacing between words in the variables, and we want to make sure that we have standardized capitalization, and especially for our state abbreviations where both characters should be capitalized. Let's run this and we'll see the results will be nice, neat addresses with the first letter of each word being capitalized and both characters in the state are capitalized, and we have removed the extra blanks. Comp BL removes blanks. Whereas compress would allow us to remove any character we specify. We'll see that soon. In 12.4, we're interested in concatenating variables. That means combining. We may have the case where first name and last name are two separate variables and we want to combine them together into one. We are creating in this piece of code 4 different variables based on the first and last variables. In name 1 and name 2, we are just putting together or squishing together Ron and Cody, whereas in name 4 with cat X, we can specify, here we have a blank, any delimiter we want to go between the first and last. So run this piece of code and you'll see the results. Name 1 and name 2 achieve the same results. Name 1 was done using 2 vertical bars. Name 2 was achieved using the cat function. Name 3, the cat s function. And name 4, where we specified our delimiter as a blank, that was the cat x function. If we would like to remove leading blanks, trailing blanks, or both, we have functions to achieve that. The left function we'll remove leading blanks, because when we're looking at a string, those leading blanks are to the left of the string. The compress function, similar to compBL, will remove unwanted characters. CompBL removed unwanted blanks, whereas compress removes any unwanted characters we specify. In the data lines here, we see various characters along with our digits for the phone numbers, parentheses, dashes, dots, and spaces. We can list all of those inside quotation marks, inside the compress function, and of course specify what variable we're looking in, and that will remove all of those unwanted characters. There is another way to achieve the same results. Let's say we didn't want to have to hunt through all of our data to find every single unwanted character. We know that we want to keep the digits, and there is a pre-programmed modifier that does just that. It's called KD, which stands for keep digits. In 12.8, we have some very sloppy data. We've got two variables, weight and height, but for the observations provided, they're not in the same units. We have kilograms and pounds. We have inches and centimeters. So the program here will change everything to metric. And the function that's going to be especially helpful for us is the find function. It will look in the weight variable and find LB. It will look in the height variable and find IN. And this I will ignore case. So it doesn't matter if LB is lowercase or uppercase if we specify this ignore case modifier. If we find this unit, then we will convert so that we will have the weight in kilograms and then the height in centimeters so that we have everything in metric. Let's run that and you'll see. We have our two new variables, weight in kilograms and height in centimeters. While the find function will look for certain characters, the find W will look for a whole word. And the difference here is that a word has a space or some other modifier before and after it. So here we're going to look in the strings that are down below, and we're going to look for Roger. And we're going to say that our words are separated by a space. And again, we're going to ignore the case. So we want to find Roger, whether or not it has a capital R or not. And looking in these data lines, the first line is a little tricky. Roger is part of Rogers, but when we specify something in quotes, we're looking for an exact match, with the exception of this ignore case modifier. So we should get a no for Will Rogers, but we should get a yes for the remaining three observations. And here we have a no because of the S we did not specify in the quotation marks, but we got a yes for all the others. The any digit function will return the position of the first digit of a variable. I'll leave that to you to run and look at that yourself. 12.11 is pretty tricky. It's dealing with the not function, which returns the position of the first character that does not belong to a specific class. And I'll talk through just this first conditional here. In the data lines, we have three variables, letters, digits, both. We're going to look at the letters variable. And if any of those have something that's not alphabetic in it, then we're going to put these two variables, subject and letters, in our output. So when I'm looking at the letters variable, Apple is all alphabetic. ICE 9 contains a digit, and help contains something that's not alphabetic or numeric. Let's run this piece of code and take a look at the results, but I'm going to leave it up to you to really study it if you need to. Here we've got the ICE 9 came back because 9 is not alphabetic. All right, in program 1212, we're looking for a substring, and that can be useful in any instance where you have a coded variable where different parts of the code have different meanings. In these data lines, we have a state, we have a gender, and we have just some other remaining numbers. And we might want to extract these individual pieces of information. So we'll use the substr function for substring. We will indicate the variable that contains the whole string first, and then the first position where we're supposed to look, then the number of characters that we are extracting. So it makes more sense with gender. We're looking at the fifth, and we're just taking that single position. So position 1, 2, 3, 4, 5, there's my M, and I just want that one character. 1, 2, 3, 4, 5, there's my F. The scan function extracts the nth word. Now in this program, we are making two variables called first and last based on this whole name variable. The scan function will look at the variable we specify, and here, since we put a 1, we're looking for the first word, and we're specifying that what delimits or separates one word from another is a space. And then we're looking at the second word and calling that the last name. Unfortunately, Alfred has a middle initial, so this code is actually going to return E for the last name. Let's take a look at that. See, last name E, because that was the second name. Well, how do we get around that? Well, we could use a -1 to say instead of looking at the first word or the second word, we're looking at the last word. All right. 1215 I'm not going to demonstrate, but it's pretty neat. This is how we do fuzzy matching. We look at spelling distances to look for similar spellings for names. But it is useful to look at translate and tran_word. Translate function will replace character for character. So we specify the variable we're looking in. And what this will do is it will replace any A's with a 1, any B's with a 2, etc. But tran_word can replace an entire word with another. And this comes in handy with standardizing addresses like we see in this example. And the author is actually using this function to do two things. It's actually removing titles from the names, replacing it with spaces, and then also it's replacing the spelled out portions of the addresses with their standard postal abbreviations. So I'll run that and you can see the results. Hold on just a moment. There we go. And we'll see we no longer have a title in the name, and we no longer have road or avenue all spelled out. Instead, we have the abbreviation. So that does it for the character functions in Chapter 12.